lecture of our chapter number 7, which is the plastic design. Okay, so first of all, in the first lecture, we will discuss up to what is the basic concept of plastic design. So now we are moving further to our revision. So you already know that in the first lecture, we will discuss up to the basic concept of plastic analysis and design. After that, we will discuss about which are the assumptions which are made while we have to design any plastic moment. Okay. After this theory, we will discuss about one very most important derivation, which is the theory of fully plastic moment, in which we have to derive one equation. So that so the so that derivation is MP is equal to Fy into Zp. Okay, in which the term Zp is called as the plastic section modulus. Okay. After this derivation, we will discuss about the three definitions. Okay, so it is first one is you can see that there are three definitions in which we will discuss about. First of all, it is shape factor. After that, we will discuss about it is load factor, and at last we will discuss about the collapse load. Okay, so this is the basic theories of the plastic design analysis. After that, you all know that there are two methods of analyze the beam, in which your first method is static method and second method is kinematic method. Okay. Now, with the help of kinematic methods, we have three types of beams. First one is simply supported beam, second one is prop cantilever beam, and last one is fixed beam. So the first question is, what is the difference between simply supported beam and prop cantilever beam? So you already know that and show in the figure that in simply supported beam, your both the supports are simple. Like you can see that in this figure it is simply supported beam, and in simply supported beam your left support is hinge support and your right support is roller support. Similarly, in prop cantilever beam, your left support is fixed support and your right support is your simple support. Okay. After these two types of beam, your next type of beam is fixed beam. And as the name is considered that in fixed beam, there both the supports are fixed. Okay. So first of all, whenever we have to analyze the beam, we have make sure that what is the difference between all these three types of beams. Okay. After completing this basic knowledge, we will discuss up to the step. Okay. So in this chapter, we have to discuss about how to find out collapse load and plastic moment. So after this basic knowledge, we will discuss about which are the steps for finding out collapse load or plastic moment. And after that, we will discuss about three derivations. Okay. So your first derivation is for simply supported beam, in which your concentrated load. Okay. So concentrated load is also called as point load, and this point load is acting at a distance small a from left support. Okay. So this is your first derivation. Your second derivation is similarly for simply supported beam and subjected to point load. But at this time, your distance is exact at the center. Okay. So this is your second derivation. And in your third derivation, it is clearly mentioned that the type of beam is prop cantilever beam, and in prop cantilever beam there is point load, and this point load is acting at a distance of small a from left support. Okay, so in the last lecture we will discuss about your case number 2 and case number 3. So now we are moving further to our next derivation. So the question is, find out collapse load or plastic moment for fixed beam. Now, the difference between last lecture and in this lecture, it is type of beam. Okay, so it is clearly mentioned that in the question that the type of beam is fixed beam. It means support of the beams is always fixed. Okay, so it is fixed beam carrying a concentrated load which is capital W at a distance small a from left support. Okay, so you can see that in this figure, as per data given, your beam is fixed beam. So your left support is also fixed support and your right support is also fixed support. Okay, now as per data given in the question, you can see that the fixed beam carrying a concentrated load. It means you can see that this is your concentrated load which is acting at a distance small a from left support. Okay, so as per data given, your figure is ready now. Now, as per discussed earlier that there are three types of there are three steps of derive the plastic moment or collapse load, in which your first step is to find out number of redundancy. Okay, so now what is the equation of number of redundancy? So it is capital R minus small r. Okay, now what is capital R? So capital R is equal to number of reactions, and you all know that this is fixed support, and the value of capital R for fixed support it is 3. So for whole the system, the value of capital R is equal to 3 plus 3, which is equal to 6. Now it is already discussed that if your both the supports takes horizontal force, then you have to neglect it. So your value of capital R NAD which is equal to 4. Now this is your capital R and capital NAD. Now the term is small r. So what is small r? Small r is number of equilibrium conditions, and it is already discussed that in your semester 3 subject mechanics of solids. So there are three equilibrium conditions, which is summation of H is equal to 0, summation of V is equal to 0, and summation of M is equal to 0. But if you are neglecting horizontal forces, then you have to neglect the equilibrium condition for horizontal forces. Now you can see that if your value of small r is equal to 3, then the value of small r NAD is equal to 2, because we have to neglect the equilibrium condition of horizontal force. Okay, now the equation of number of redundancy is equal to capital R minus small r. So it is 4 minus 2, which is equal to 2. Okay, so this is the end of your step number 1. Now your step number 2 is number of plastic moment, and the equation is number of redundancy plus 1. So it is 2 plus 1 is equal to 3. It means in this whole system there are 3 points which takes moment. So which points? So it is at the point of load and 2 fixed support. Okay, so this is the end of your step number 2. Now we are moving further to step number 3, which is the kinematic method, in which you have to find out external force, or it is also called as external work done and internal work done. Okay, so now for step number 3, first of all we have to find out external work done. So for external work done, you have to draw some deflection shape. Okay, now for fixed beam, you can see that this is your point load, and this point load is considered as your collapse load, and this collapse load is acting at a distance of small a from left support. So this both the distance are different. So if the distance is different, then the deflection angle is also different. Okay, so now this is theta, this is theta 1, and at the point of load, the deflection angle is the summation of both, so it is theta plus theta 1. Okay, now what is this value? This value is A into theta. You can see that you have to find out x. So if we are calculating it from left side, so it is x into, sorry, A into theta, and if we are calculating it from right side, it is B into theta 1. Okay, now there is one relation, it is A theta is equal to B theta 1, and we have to make theta 1 is our subject, so it gives the relation between theta 1 and theta, so it is theta 1 is equal to A theta by B. Now, the term external work done. External work done means the load which are acting from external work done. Okay. So, it is load into deflection under that load. So, it is W into this value is A theta. So, your value of external work done is WC into A theta. Now, the term internal work done. So it is already discussed that in this whole system there are 3 points which takes load. So this point, the moment is MP. So your internal work done is MP into theta. At this point it is MP into theta plus theta 1, and at this point it is MP into theta 1. Okay, now if we have to equate both the values, it is compulsory that both the values have in the same term. So you can see that your external work done is in the form of theta. So first of all, you have to convert your internal work done in the form of theta. Okay, so after calculating and after converting your term theta 1 to theta, your final calculation of internal work done is mp theta into 12 by b. Now we have to equalize both the values. So it is wc into a theta is equal to mp theta 12 by b. Okay. Now sometimes in GTU, if work done is asked or collapse load is asked, that then you have to made your WC is your subject, and at the same time if plastic moment is to be asked, then you have to make MP is your subject. Okay, so students, this is the end of your case number 4. Now similar work to be done in your case number 5. So in case number 5, the question is find out collapse load or plastic moment for fixed beam carrying a concentrated load at the center of span. Now the difference between case number 4 and case number 5 is only that in case number 4 the point load is acting at some distance and it is small a from left support, and in this case the load is acting exact at the center. Okay, so your step number 1 and step number 2 is remain same. So your value of number of redundancy is equal to 2 and number of plastic moment is equal to 3. It means in the whole systems there is 3 points which takes moment. Now we are moving further to step number 3, which is kinematic method. So for kinematic method, first of all we have to make deflection shape. So you can see that if the load is acting at exact at the center, then your deflection angle is similar. So you can see that your left side deflection angle is theta. This is also theta. Then the deflection angle exact at the center, it is 2 theta. Okay, now we are moving further to external work done. So the equation of external work done is load into this deflection value. So it is WC into L by 2 into theta. Now the term internal work done. So for internal work done, it is already discussed that in this whole system, there are 3 points which takes moment. So at this point, it is mp into theta. At this point, it is mp into 2 theta. And at this point, it is mp into theta. So after calculating all this calculation, your total internal work done is 4 mp theta. Now you have to equalize both the values because you can see that your both the term is in the form of theta. Okay. After equalize both the values as per data given in the exam, you have to make your subject WC or MP. If in exam it is clearly mentioned that find out collapse load, so you have to make WC is your subject, and if in the question it is clearly mentioned that find out plastic moment, so you have to make MP is your subject. Okay students, so this is the end of your today's session. Thank you.